Hi everyone, Krishna this side. In this video, I'll be covering this Leetcode problem 2434 using a robot to print lexicographically smallest string. So let us go through the problem statement first, and then I'll explain you the brute force approach as well as the best approach that we can get it, and I'll write down the solution for that one. So you are given a string S and a robot that currently holds an empty string T. Apply one of the following operations until S and T both are empty. Remove the first character of string S, give it to the robot. Robot will append this character to string T. Remove the last character of string T, give it to the robot. Robot will write this character on a paper. Okay. So yes, of course, if T has any single character as well, then we can easily perform this operation. Okay. Because they are saying apply any one of the following operations. Okay. So until T has a character, we cannot perform this one. Okay. So T should have at least a single character to perform this operation. So whatever the character that is there in the last of the T string that we have, we just need to remove it and we have to write it on the paper. So we need to return lexicographically smallest string that can be written on a paper. So yes, of course, we have to make sure that whatever the smallest string that we can get it lexicographically, that is something what we have to write it down as an answer. Okay. So if we look into this first example, this is the A. So of course, we can remove this character and append it into the T, and now we are free to just remove that character from the T and write it on a paper. But is it going to be the lexicographically smallest answer? No, right? So yes, we keep it into the T. Again we check for the Z. Again we remove it from this S, add it onto the T, and still with this removing this Z character from the T, it is not going to be lexicographically smallest one. Again we remove A from the S, we add it into the T. So now we can remove this A, and also of course we are end of the string. So whatever the data that we have, we can keep on removing it and add it into the P. So we remove the last character, add it into the P, remove this second last character because this is gone, right? So this is something what we appended. Now remove this character, remaining character, and add it into the Z. So this is like lexicographically smallest answer that we can get, right? So we can start writing this solution at from any point in time. Okay, it is not necessary that we have to go to the last of this yes character and then only we have to write it down. It is not like that. Okay, so if A appears right over here, since A is the smallest character that we can get it, so from there we can keep on removing the character from the T. So if A has been appeared right over here, we remove that character, append it into the P. Again next character whatever we get, those characters we keep on removing if they are smallest ones, and keep on adding it. So until we get the smallest string that we can perform from this one, we have to do that operation. So we can create many strings from this one, right? So we can add it to T, removing from here and append it into the P. With that one we can get another string. So there are like many possibilities to get different strings, but out of all those possibilities, whatever the smallest string that we can get, that is something what we have to write it down. Okay, so what is the brute force approach that we can think of? We can actually start I mean, see, the first thing that we have to consider right over here is we have to we are actually performing this push pop kind of operation, right? So basically we are removing this character, we are popping this character, pushing this character kind of operations. That is something what we are doing. So definitely stack is something what we have to consider right over here. Okay, so that is the first idea that we can get. Okay, stack is something what we can consider because we have to, once we push it somewhere, we have to either remove it or push other characters into that one. Now once we get a smallest one, we can get it out of there, and remaining character either we can pop it or else the new characters we can keep on pushing there. So whatever the characters that are there in the bottom, those characters we one by one from the top, one by one we can get them and keep on forming the string. So definitely for this particular kind of operation, stack is something what we require. So yes, stack is something what we will consider right over here. Now, what we can think of is like we can perform n number of operations, right? Like for each index, we whenever we add it into the T, either we push it or pop it. Okay, push it like this character we pushed it, or this character is something what we directly append it. That is like we directly popped it and add it into the P. So this is something like these operations we are performing for each of the index, right? So it means like we can try it out all the different possibilities that we can get in the brute force approach, and we can write it down the solution. So simple DFS approach is like we start from the zeroth index, we create a string builder to append the characters, and until the string builder size is actually equals to the answers, this yes characters length. So we keep on adding the characters into the string builders, and stack is something what we will use. So in the DFS, what we will do is the base condition is the moment we reach to the last index is equals to s dot length and the stack is empty, because from the stack only we are getting the data and adding it into the answer string. So if that is the case, so whatever the answer that currently it is holding, so currently the answer is actually it is exceeding from the C. Okay, G is the last character that we can have. This is actually basically holding only English lowercase letters, right? So after Z, this particular tilde sign is something what we will get. So that is something what the answer that I am holding. So that whatever the string that we form, it should be less than this answer. Okay, by default currently. That's why I added the maximum answers a string that we can get it by default. Okay, initially. So yes, we are basically the base condition is simple, pretty much simple. So we compare the whatever the string that we form, and if that is the less than this answer, so answer we update it and we return from there. So that is the base condition that we can have. Okay, in the DFS. So now we check if the index is actually less than length, then we push that data into the stack and we simply call for the next index. So we keep on doing these operations, and yes, so the moment we reach index equals length, this if condition is not going to work. So we check that if stack is empty, stack is not empty, so still we didn't form this string at any point in time, right? So we what we do is we pop the data from the stack, we append it into the into the string builder, and we call the DFS again. We again check it is not satisfying, this is also not satisfying. Again we pop the data from the stack, again append that data. So from the last character we keep on building the string until the stack is empty. Now the stack is empty, so what we can do is the string builder string is something what we formed with the help of these characters using the stack. Now we check that answer is less than or equals to it is. So we return that once the answer is updated, we return from there. So one possible string is something what we formed here. Now what we can do is we need to, once we are backtracking, we definitely need to hold those characters into the stack. So what we do is we delete the character from the string and we push that data into the stack. We backtrack to this particular one. Now what we do is whatever the character that is there in the stack, we pop it, since it is basically holding into the answer. And now again we backtrack, again we pop it, again we backtrack. So this way what we do is basically we keep on performing different strings that are possible at particular index. Okay, for the last index, whatever the string that is possible, by popping it we did it. Now that is something what available into the string builder. So we keep on performing these operations. Okay, so by orally speaking, this is a bit tricky to explain you, but definitely if you guys want this solution properly to explain with the help of the recursion tree, I'll make a video for you guys. But for now, just this is the answer that we get. So this backtracking is something what you guys need to think of in your mind. Until that you guys won't get this, like why we are doing this backtrack and popping this data and again deleting the characters. But yes, if you guys want this solution properly to explain, if of course if you comment, I'll make sure to explain you guys properly. But yes, this is how we can write it. So with this help of this one, of course all this exploring different possibilities, it is like 2 to the power of n is the time complexity that we will going to get. So it is not going to be optimal one. Of course TL is something what we will hit, because this constraint itself saying that 10 to the power of 5 is what length we have. And to the power of 10 to the power of 5 is something of course is not going to be accepted. We will going to hit TLE. So there should be some better approaches, right? So what are the possibilities, right? Like just we can think, we can use the stack, of course. So let us go through an image that I have prepared for you. So what we can do is we will create a frequency array. In the frequency array, whatever the character that are appeared, those frequencies we will add it into this frequency array. Okay, so in this frequency array, D actually appeared once, E actually appeared once, O actually appeared two times if we look into this example, right? And P appeared once, yes, and TR appeared once. Okay, so we prepared this frequency array. In the frequency array, at 0 to index, A is actually pointing, so that is something what we can consider, and last index Z is actually pointing. Based on that, this frequency array is something what we have prepared. Now, once we fill the frequency array, what we can do is we can create a pointer. Basically, it is pointing to the character which is having frequency greater than 0. Okay, so once we found this character, what we can do is we basically now keep on looking into the characters from the string. Okay, from the 0th index of the string, we keep on checking whatever the character that we get, we put it either into the stack, or if it is the less character. Okay, so with see, this frequency array is going to help us. How? That is something what the question that we get it, right? So see, whatever the smallest character that we have, right, it is actually available into the string. This d is something what we have the smallest character, and with the help of d only we will going to get the lexicographically smallest string. Okay, without d, do you even think that any other character, if we try to form a string, is it going to be a smallest lexicographical answer? No, right? We definitely have to start our string from d. Okay, that is something what going to give us the lexicographically smallest answer. Okay, so that is clear for us. So with the help of this frequency array and the pointer, we can actually check that if we are actually reached to this d character. If we reach to the d character, we simply start forming the string and we keep on reducing their frequency. Okay, now once this d is something what we got, we reduce this frequency, we update the pointer to next smallest character that we have, that is e, and we check that if its frequency is actually greater than 0, if it is actually already appeared. Okay, since e might have already appeared if we look into this string, right? So whatever the character that we are at, what we basically do is simply at currently t is the character that we have in the string, so what we do is we just reduce this frequency to 1. Okay, so now since t has only one frequency, so it got updated to 0. We go to the next character, we check that s is frequency is 1, so we reduce its frequency. But only thing is, by doing this, we just have to check that whatever the pointer that we are pointing at, we just have to compare this current value with that pointer's value. Okay, if it is less than this current pointer's value, let us suppose if we have a character appeared right over into this string, the pointer is basically pointing to a only. Okay, so if we got the a, so we basically have to check that the frequency of a, we simply reduce first in the first place only. The moment we get the character, whatever the character from the string, we check that we reduce its frequency and put it into the stack. So now once the moment we reduce this frequency, whatever the pointer that we have, we basically point to the next character's frequency which is greater than 0. Okay, that is the second thing that we do. Now once we move this pointer's character, we basically have to check that whatever the character that we have into the stack. Okay, we basically just have to check that if the pointer is actually greater than the current stack element. If it is the case, so we simply append that character. Okay, so I have prepared this one with the help of this stack and whatever the relation that I'm talking about, the algo that we are discussing, you guys will get the clarity of all that. So we simply fill the frequency array. That is the thing, first thing that we have done. Now we created a pointer, and the pointer is basically pointing to frequency which is greater than 0. So currently the pointer is pointing to d, and of course the answer should start with d, then only we will going to get the least frequency, least lexicographical answer, right? The smallest lexicographical answer is what we will get if we start with the d. Okay, that is the second thing. Now move the next pointers, move this pointer to the frequency character greater than 0. That is something what we have done. The pointer is basically pointing to d. Now push the data into the stack and reduce its frequency. The moment we get any character, okay, we just push it into the stack and reduce its frequency from this frequency array. Okay, so that is something what we do. Now compare the pointer with the stack top element. So whatever the stack's top element that we have, we keep on comparing it, and if it is less, if whatever the stack data is less than the pointer's value, what we do is we basically append it into the answer. Okay, let us look into the stacks and whatever the array that we have, and based on this we will keep on looking into the answers. Okay, so this stack is something what currently we have. The t is something what we pushed into the stack. The currently pointer is actually pointing to d, so we compare, check that if d is less than t, it is not right, so we simply continue from there. Since t is actually greater than this d, it is having more high value than this d, so of course this is not the best answer that we can perform, so we simply push it into the stack. We reduce its frequency to 0. Initially it was 1, so we reduced its frequency to 0. Okay, this frequency reduction is also something what you guys will get in future if still didn't get you. uh, so next is like yes is the character that we get, so we simply push it. we reduce its frequency. The pointer is currently pointing to D, so basically S is greater than D. So of course this is not the best answer that we can get with this S, so we simply continue. Now E is the character that we get from the string. E is the next character, right? So E is something what we push into the string. E's frequency is something what we reduced. Pointer is currently pointing to D, so we simply continue from there, because this is from the E also we are not going to get the best answer. Now the next character is D. D is something what we get. So D's frequency we reduced. Now the pointer should point to the frequency of the character which is greater than 0. So the pointer is actually pointing to 0, O character, because O is the next character, right? Rest all the having 0. E is also got updated to 0. E's frequency. Now pointer is actually pointing to O here. Okay, pointer is pointing to O. Now pointer is actually pointing to O. So we check that if D is actually less than this pointer's value. Of course it is less, because D is less than O. So what we can do is now simply we pop it and append it into the answer. Since the value is less, so we pop it and append it to answer. Now next character is E. So it is like while inside a while loop we are checking that whatever the characters that are less, because the pointer might point to the last character and all these characters are got appended into the string, so we can keep on popping them and perform the smallest strings that we can get it, right? So that's how we do this particular operation. So D is something what got removed, E is something what removed, and we added it into the string. Now yes, we check with the O. It is not so, since O is the smallest one, so until we get O we cannot create the string with the S, right? That is the whole point right over here. So still we have to hit O, and we get that O to reach to this S. So the moment we get now O character, we reduce its frequency to 1. Now we check that O is less than or equals to O, so we simply pop it and append it into the answer. So currently whatever that character we are at, if that character is something what we get, the pointer is actually pointing to that same pointer, so we simply can get that character and append it, because that is the smallest answer, smallest character that we can get it, right? So simply we pop it and append it into the answer. Now again we got P, we add it. Since O is less than P, so it is not the best answer. Still we have to hit O again. So O is something got added. Now once we add the O, right, once we add the O, we are out of it. So we simply pop it. Since O is actually the pointer actually pointed to P, O is something what smaller than P, so O is something what we popped. And again P is something where pointer is pointing, right? So P is the top element, so we still can pop it P, and we append it. Now since we end from the string, we simply come out of it, and whatever the remaining characters that we have, those characters we keep on adding it into the answer string. Okay, let us write down the code, and again I can try to explain you guys still if you guys didn't get it. And for this DFS approach I can explain you guys in a better way, but it requires more time. So yes, of course, if you guys want that particular solution properly, just do let me know in the comment section. I'll write down the solution as well. So first thing is like create a frequency array. Okay, it is going to have a length of 26, and start filling this frequency array with whatever the characters that we have into this string. So let us get index for that particular character, and the zeroth index is actually pointing to A. So for that what we can do is yes dot caret I, if it is A, if the character is A. Okay, so A minus A basically gives 0. So at 0th location A is what we are pointing. Okay, and I am actually wanted this pointer to point at the index, smallest index. Okay, so what I do is math dot mean pointer index based on whatever the value. So currently I'll point it to 26, so that whatever the smallest index that I get, there the pointer will point. Okay, and let us update this frequency of this index plus plus. Okay, so index is something what like we are just converting it from a character A into 0th index, character B into first index, character C if we get that into the 25th index. Okay, and based on that we are keep on updating this frequency array. Now once we create the frequency array, let us create a string builder, new string builder. So in this string builder, what we do is we start going from this string again and check if it is the smallest character based on the frequency array. Sorry for this all. Okay, I was actually speaking and then writing the solution, so at both the time it is not giving the correct typo that I want to type right over here. Okay, we are looping from the 0th index, we go to the last index, get the current index for that character. Yes, dot caret I say, and reduces frequency, that particular index frequency, and let us create a stack in which I just want to push the data. So it is basically holding integer type of data, cat new stack. Okay, in the stack, let us push this data, whatever we got, stack dot push idx. If it is a 0 is something what we push. If it is G, 25 is something what we push into the stack, and we reduce their frequency as well. Now the thing is, like, we have to keep on updating the pointer as well, right? So we check that if pointer is less than 26 and the frequency of pointer, whatever wherever the pointer currently pointing, so if the frequency of pointer is equals 0, that means we have to update the pointer, so it should point somewhere which is having the frequency greater than 0. So simple thing, right? Currently pointer is actually pointing to t, so the moment we got d, we reduce its frequency to 0. Now since 0 and e is also 0, so the pointer should point somewhere the frequency is actually greater than 0, so the pointer should move, right? For that, this condition basically satisfies us. So we are keep on updating, checking the pointer's value if it is pointing to the correct location. Now once this is done, what we do is basically we check into this stack, whatever the stack data that we have. Stack is basically, this is the first condition, stack is empty. If it is not empty, and stack dot peak, whatever the peak data that we have, if it is less than or equals to the pointer. So currently pointer is, now when we reach at this condition, right? So the pointer was actually pointing to d. The moment we got the d, we push it into the stack. Now the pointer actually moved to o. Now we basically checking the pointer if the pointer is actually greater than whatever the character that are there into the stack in a while loop. Okay, whatever the data that we have, so since d is also appended, e is also appended, these characters we can pop it and we can perform the operation that we want to do, so we can keep on appending it into the string. So what I do is I'll create a char out of this pick element that we have. So just convert this stack dot pop the top element and add a, so this will now convert back into the uh, character. Okay, so we initially we convert it into the 0 based indexing from 0 to 25. Now again, if we add a, it will take us to 97, that character, and we simply convert that into the ask character value, whatever we get. Okay, now once we get the character, the same character, in the character, what we do is we simply append it into the string builder. So what is the character? That is something what we appended. Now this keep on doing. Okay, this while loop also keep on doing it. So here this is like d popped out, e popped out, appended into the string. Now we check if yes is less than o, it is not, right? So still o is the smallest character that we can get it from the string, which will be appear in a future of the string. So we do not perform that operation, we go out of this while loop, whatever the while loop we have created. Now again, we keep on looking for the next character so that we get, and we keep on reducing their frequencies, append it into the stack, we update the pointers if needed, and we keep on popping the data if also required. Now once this is done, whatever the remaining data that is available in the stack, those needs to be appended into the string. So stack is empty. Until stack is empty, what we do is we perform the same operation again, get the character from the stack, uh, whatever the index that we have, add it a and get the character, append it into the string, and at the end return this string. Okay, so that's all from this one. Let us run this code. So if we talk about the time complexity, right? So let us submit this code as well. Simply, if we look here, the frequency array is something what we have created right over here. It is of 26 size. Okay, so the pointer is basically so frequency is like the space whatever we are using, it is going to be yes dot length, because the string builder is something what we are performing right over here. So space is like same. It is something what we have to return also, so we don't have to think about the space as well. But the time complexity, if we talk about, it is going to be big O of n plus 26 times if the pointer is actually moving. So yes, it is going to be big O of n approximately only. So with this one, we actually able to reduce the complexity from the brute force approach to the power of n to n. Okay. So that's all from this particular video. If you guys want the brute force solution to be explained properly, just to get the idea like how this recursion and all things works, just do let me know. I'll try to explain it as best as possible. Thank you for watching this video. Bye bye.